This is mounted to the vacuum chamber, and this part is the thermal conductor and shield. I think vacuum here is single part for detector. This flange is mounted to the big vacuum chamber, and this is like a shield, a thermal shield. It is bolted to flange. Here there is no connection, and it was insulated with such plastic evacuation port sealed with door seal, and one can screw such screw, American thread, but nothing happens. This pipe feels very warm by hand. It's like duar insulating, and inside is vacuum, and I have unbolted all the screws, but nothing comes apart. So I try this razor blade method, and it seems to work. There was indeed vacuum inside, and here we see the cold bridge with flexible copper bride. We see a hole in the middle of the screw. That's for pumping out air, vacuum. The cables have Teflon insulation. From high voltage connector comes two cables, and there is one thicker cable going to the output. This thing just came apart. There is beryllium window at the end, and here we have drift detector. I could not figure yet about high voltage where it goes. Here is something which is hard to scratch. Could not scratch it by a knife. I could scratch aluminum, but not this. It's like ceramic. And there is this transparent thing. I was wondering what it is. Actually, it's optical cable. It is for calibration of the detector, and that explains what we have here. We have going into transparent optical fiber output from red LED. There is thermal insulation with some fiberglass and mylar film to protect the copper and reflect the heat. It's warm by hand touching, no heat conductivity. Under the mylar film was hidden soldering place. The black wire from the high voltage port actually goes to the ring of the photo detector, and another wire marked white and blue actually it's soldered together with the red wire which goes to detector, and there is one more red wire which could be for sensing something, which goes back to the connector. And I am surprised that to the detector come so many wires. I could count 7. So there is field effect transistor and maybe something else. For the liquid nitrogen sensing, there is a diodes which acts as a temperature sensor. Looks like a regular silicon diode. Yeah, maybe in the cold head there is some temperature controller as well. More about the detector, you can look at it from the back side and see that it has a pin, and the black thing, it's actually anodized aluminum. I could disassemble the vacuum pumping out valve. It's actually simple. You pump vacuum and then it will jump back into place. The screws attaching to a cryostat also have holes for vacuum. Cryostat removed. Inside the bias box, minus 750 volts goes to one wire through a large resistor and capacitor filter, and other one goes to ground. High voltage goes to the black wire, and the white with blue, it is actually ground. Detector, we see that negative high voltage goes to the detector front surface. Around the detector is earth, aluminum, and plastic insulator. And then electrons go to the center of the detector, where they are collected. High voltage DC is necessary to create a large PN junction, where it has a small capacitance, and small capacitance means that one can charge it up with a small charge and detect small energy X-rays with good resolution. The screws with a drilled hole. Not sure about the dewar. If it is connected to this pumping hole, and if one needs to pump vacuum on its walls, between its walls as well, everything is welded, hermetic. This brass part is so massive because the whole weight of the detector and cryostat was hanging only on it.